Hello, my name is Noah Abji, and today we are going to learn how to find and interpret patterns in sequences of numbers. So let's go ahead and look at some sequences of numbers. But first, what is a sequence of numbers? Well, a sequence of numbers is a list of numbers that follow a certain rule in order to get to the next number. So let's look at some examples so I can actually explain what this means. So here's an example of a sequence of numbers. It goes 4, 23, 42, 61, and then 80. And you've probably seen these before. They have a certain pattern to them, essentially. Basically, you start at one number, and then given a certain pattern, you get to the next number, and the next number, and the next number. And that always follows the same rule as before. Now, one important piece of terminology that we should learn is actually called the term. So a term in a sequence of numbers, so remember this is a sequence of numbers, is just one of the numbers. So one number in the sequence. So in the sequence of numbers. Sequence. So if I were to say the first term is 4, then that would make the second term 23. And the third term would be 42, and the fourth term would be 61, and so on. And there's a reason that this is important. This is how we recognize how patterns are made in sequences of numbers. So let's try to figure out the pattern in this sequence of numbers. Well, since it's the same pattern to get from one number to the next, let's first look at these two numbers and see, is there any specific pattern to get from 4 to 23? Well, I can't really multiply 4 by anything. It's not an obvious multiple of 4. I mean, I could do 4 times 5 3/4, but that's a really ugly number. So I'm guessing that's probably not the pattern to get from one number to the next, or from one term to the next term. Another thing that I could do is I could do 4 plus 19 to get to 23. 4 plus 19 is 23. So now that I have two different patterns that works, let's actually test them on the next number to see if they're the same. So I'm going to test this one first because it's a little bit more easy to test. You're adding 19 rather than multiplying by a fraction. So 23 plus 19 does in fact equal 42. And if we test it on the next term and add 19, we get to 61, and so on. Adding 19 gets us to 80. So adding 19 is the rule. So the way that we can express that rule or interpret the rule is we can say each term is 19 greater than the previous term. So each term is 19 greater than the previous term. And I just have a few other sequences of numbers here that I think we should practice with in order to get this solidified down. So the next is 2, 6, 18, 54, and 162. So let's do the same thing here. Let's see, are there any specific patterns to get from one number to the next that work for everything? Well, since we added last time, let's try that first. To get from 2 to 6, we can add 4. So if we add 4, we get from 2 to 6. But that doesn't work for 6 to 18. To get from 6 to 18, we add 12. And to get from 18 to 54, we're going to add 36. So obviously, adding isn't what the rule is for this one. Now, last time we also tried multiplying, but we ended up with a fraction when we were multiplying. Remember, we had 4 times 5 3/4. And that's not very nice. But in this case, we can multiply 2 times 3 to get 6. Now, let's test that for the rest of the terms. 6 times 3 equals 18. And 18 times 3 equals 54. And 54 times 3 equals 162. So multiplying by 3 is our pattern. So the way that we can interpret this pattern is by saying each term, remember a term is a number, is 3 times greater because we're being multiplied by 3. So 3 times greater than the previous term. So with an example, if we had the number 6, 6 is one of our terms. Now, therefore, according to our rule, it should be 3 times greater than the previous term. The previous term is the one that comes before it, that's 2. And 6 is, in fact, 3 times greater than 2. So therefore, that is our rule for this sequence of numbers. And for our last sequence of numbers, now we're actually going down for this one. So this one's a little bit trickier, but I still think we can figure it out. Now, I don't think we're going to be doing any division for this one because it doesn't seem like we're dividing each number by the same thing. That'd be kind of complicated because they're so close to each other. So instead of trying addition or multiplication or division, let's try subtraction. So 90 minus 8 is going to be equal to 82. Now let's test the minus 8 for another term. 82 minus 8 does in fact equal 74. And then if we subtract 8, and then we subtract 8, we keep getting the next term in the sequence. So to interpret this last sequence, we can say that each term is 8 less than the previous term, because we're subtracting. And if we were to test that with some terms, so for example, 66 is 8 less than the previous term, which is 74, because to get from 74 to 66, we subtracted 8, and that's how we got there. Now, there's one other thing that we can do with these rules. Now, we figured out the rules. We've interpreted the rules by giving these sentences telling us what the rules are. But we can also find terms that aren't there. So let's say I wanted to find what the next term would be. And let me erase that because that wasn't great. Let me say I wanted to find what the next term would be after 80. So add a comma here. And I wanted to find this term right here. Well, how would I do that? Well, we know that each term is 19 greater than the previous term. And so to get from one term to the next, we add 19. Now, it doesn't matter if we're not given those original terms. This rule is always going to apply. So we can just add 19 to 80 to get to the next term. And 80 plus 19 is going to equal to 99. So our next term in this sequence of numbers is going to be 99. What about this one? Let's say we multiply by 3 every time, then to find the next term, logically, we should just multiply by 3 again. So to find this next term, we should multiply by 3 again. So we do 162 times 3, so we get 6, 8, carry 1, and 486. So 486 is the next term in this sequence. And sometimes, especially with the geometric sequences, which is what we call it when we multiply, we can get really big numbers. So we usually don't go out to that many terms for those ones. And then what about this one? Let's try something different for this one. Instead of finding the next term and just subtracting 8, what if we were to find the previous term, the one that comes before 90? Well, because we're subtracting 8 each time, if we're going the opposite direction, we should do the opposite rule. To get from 90 to the next term, 82, we subtract 8. So to get from 90 to the previous term, we should add 8. So 90 plus 8 is 98. And this makes sense because to get from 98 to 90, then we subtract 8, and that is our rule because each term is 8 less than the previous term. If we were to do it with this one, we would divide by 3. So we would do divided by 3 to get from 2 to the previous term. And that would end up with a fraction, so I'm not going to go there. But in order to find missing terms, we need to be able to go either way to find the terms that we want. But the most important step is always to find and interpret the pattern first. All right, so let's do some review questions. So find the pattern for each of these following sequences of numbers, and then find the terms that are missing, basically the ones that are represented by the lines at the bottom to show that they're missing. If you'd like to try it, I'll give you a few seconds to pause the video before I explain the answer. All right, so here were the answers to these questions. So first, each term is 14 greater than the previous term, and then in red I have the missing terms. So the first one would be 3, and I'll just write that in. It'd be 3, and the last one would be 73. And then for the second one, each term is twice the previous term, and the missing terms are 4 and 16. So let's figure out how to find these patterns. Now, in each sequence of numbers, remember, all we need to do is find a pattern between two numbers and see if it works for the rest of them. So we can just choose any two numbers that we have here, and I chose 17 and 31, and look for a pattern and see if that works for the next term, and the next term, and so on. So to get from 17 to 31, we can add instead of 17, we can add 14. So we can add 14 to get from 17 to 31. And we can also multiply by something. But let's test adding 14 first. So we can add 14 here. And then 31 plus 14 is also going to be equal to, 14 plus 31 is going to equal to 45. And then if we add 14 again, we get 59. So that means that adding 14 is the pattern here. So if we were to interpret this, we would write that each term is going to be 14 greater, since we had just added 14, is 14 greater than the previous term. And that makes sense because, for example, 31 is 14 greater than the previous term, which is 17, because we added 14 to get there. So now we have to find these missing terms, and I'll erase them in these lines so we can actually find them here. Now, to go from 59 to the next term, we just follow the pattern. We add 14 each time. So we're going to add 14 here, and 59 plus 14 is going to be equal to 73. And to go from 17 to the previous term, we actually have to do the opposite. Since we're going the opposite way, we subtract 14 to get from 17 to the previous term, and that would be 3. And that makes sense because to go from 3 to 17, to go forwards in the pattern, we add 14, and therefore we're following our rule. All right, so now let's do the next one. And this next one is a little bit harder because you can see we're missing terms in the middle. We're not missing them at the end or the beginning. So 2, and then something, and then 8, and then also something, and then 32. All right, so let's say we are going to try to come up with some type of pattern to get here. Here's what we're going to do. We're going to see, instead of seeing, is there a pattern to get from here to here, or is there a pattern to get from here to here, we're going to see, is there a pattern to get from here all the way to here? Because if you think about it, this will give us whether or not we're multiplying or adding as our pattern. Let's use this previous question as an example. We know that this term is 73, and we know that we add 14 each time. But let's say I wanted to find the pattern to get from this term to this term, so I skip one term. Then instead of adding 14, we add 28, or basically adding 14 twice. And that rule would apply to get from here to here. To get from 45 to 73, we would also add 28, and so on, which means that we can actually find the pattern to go multiple terms out in order to see, well, are we multiplying, adding, subtracting, or dividing? So we're going to actually skip terms here and see if we can find a pattern to go from 2 to 8 and then 8 to 32, because we're going 2 terms out each time. So to go from 2 to 8, we can either add 6 or we can multiply by 4. So let's test adding 6 first. To go from 8 to 32, well, adding 6 doesn't work. We would have to add 24 to get from 8 to 32. However, multiplying by 4 does work, which means that we're going to be multiplying by something to get from one term to the next. So now that we know that we're multiplying, we can try and find a pattern out of these numbers, even though there's ones missing. So let's see if this pattern works. Let's say we wanted to get to the next term. We know to get from here to here, we multiply by 4. So what if to get from here to here, we multiply by 3? Well, let's test it. 2 times 3 would be 6, and then 6 times 3, well, that would be 18. So that wouldn't work. That would be 18. So it's not multiplying by 3. What about multiplying by 2? Since we know we're multiplying. 2 times 2 is going to be equal to 4, and 4 times 2 is going to be equal to 8. Well, that worked out, but let's test it for this other missing term. 8 times 2 is going to be 16, and then 16 times 2 is equal to 32. And therefore, multiplying by 2 is going to be our pattern. And by doing that, we actually found our missing terms anyway, 4 and 16, because we had to find them to find the pattern. So we know our missing terms are 4 and then 16, and now we can write that our pattern is that each term is twice the previous term, because we're multiplying by 2 to get to the next term in each of these in the sequence. That's all, and thank you for watching.